other things in our bell ringer have things that you should have, or that you want to know how to do in order to work through the stuff we're doing. So if you'd like to, again, since you are at home or at least getting some practice, I'd take a second, pause the video, and try these 3 things. I'll start answering these in about 5 seconds and then move on from there. So on the first one, if you remember, anytime you have x's on both sides, you cannot do anything unless your x's actually have what I'd say declared a side. So what you do is, or the best way to do it is to pick the smaller of the x's and simply move it by using its opposite. So we will move the positive 4x by using a negative 4x, but of course it's going to move over here. When that happens, the 4x's go away, the 10 comes down, 6 minus 4 is 2, and the 2 comes down. So again, that leaves you what we call, or what I like to call, the home base, which is where you have x and a number on one side and just a number on the other side. So from there, you're going to go ahead and move the number, which again is the 2. So you're going to move the 2 by subtracting it, bringing down 8 and 2x. And since that is 2 times x, you then divide by 2, getting 4 equals x as your answer. In terms of angles, remember that acute angles are angles that are less than 90. Right angles are angles that equal 90. Obtuse angles are angles that are larger than 90. And straight angles are just straight, so 180 degrees. So once you see that this is bigger than 90 degrees, again, if 90 degrees is your mark, you're pretty much your main judge. As soon as it's bigger than 90 degrees, it means it would be obtuse. I'm sorry, I have these things here. So again, less than 90 is a small angle, so what people like to say, or to help remember, is a cute little angle. Right angle, again, is 90 degrees. It's shaped like an L, like the corner of your paper. Again, obtuse angle is going to be bigger than 90, but it's not straight. And then, of course, again, a straight angle is what it is there. It's 180 degrees. So I guess I'll go back and answer these. This one here should have been obtuse. This one should have been straight because it is 180. This should have been acute because it's less than 90. And that one should have been right. Number 3 is, again, kind of what you have to kind of get into at some point, which is being able to read a word problem and then work your way through it. It says the sum of 3 numbers is 180. And if two of the numbers are 54 and 102, find the third number. This is, again, a skill you're going to need at some point. Sum, again, means add. You learned that a couple years ago, or maybe a year ago, in algebra. And so what that means is we want to add what we have. So 54 is a number, 102 is a number because it says 2 of those are there. I put a question mark there, which actually what we'll start doing at some point is just putting an X. Probably we'll do it today. And then, so 54 plus 102 plus something we don't know is 180 because it says the sum is 180. Whenever you have like terms on one side, you want to put those two together. So 54 and 102 make 156. From there, because x is by it, or you want to get x by itself, you're going to move the 156 by subtracting it from both sides, getting your final answer of x equals 24. So getting to the actual lesson, I'm just going to walk through this so you at least see what's going on. Feel free, again, if you're at home, to email me and I'll send you a file with the stuff that we did in class. There's 2 ways to classify an triangle, I'm sorry. One is by the angle and one is by the side. Unfortunately, the only way you can really be good at this is to actually memorize it. It's not something it probably won't kill you if you don't understand all of them, but you do want to at least get a little bit of it and kind of understand what makes the stuff work. An acute triangle, if you remember, an acute angle is less than 90. So an acute triangle is where every angle is less than 90. So every angle in that triangle is going to be acute. So notice that's acute because it's less than 90. That is acute because it's less than 90. That is also acute because it's less than 90. And by the way, if you have access to a printer and you want to take notes on this, there is should be a PDF off to the side in your activities page that you can print out and actually get this stuff down so you can have it in case you need it. Another triangle is called an obtuse triangle. Again, if you remember, acute means it's less than 90, obtuse means it's bigger than 90, and the easiest way to think about an obtuse triangle is you see an obtuse angle. So you'd see an angle that just looks weird because the word obtuse typically means weird, but it would just be a large angle. So in this triangle, that's acute, big deal. That's acute, big deal. But once you see an angle bigger than 90, that has to be an obtuse triangle. Here's the trick. You can't have more than one obtuse angle because there's only 180 degrees fitting, which means once you get 2 angles bigger than 90, you've passed 180, which doesn't work. I've kind of gave you the answer to the end of this one also. A right triangle just has a right angle. So again, if you see an L-shaped angle that is marked as 90 degrees, then it's a right angle or a right triangle. Again, we don't care what these two are. Those two would be acute, but kind of like the obtuse triangle, once you see a 90-degree angle in there, it makes it a right triangle. So with that said, we also have an equiangular triangle. And what that means is that all angles are equal, and the clue is in the name. So when you look at equa, that's like equal, and then of course angular means angle. So every angle or equal angle triangle, which means everything is the same. So what you're looking at here is that all three of these things would be congruent or equal. These marks, whenever you see them on the inside, means that if each of these has one mark, it means that each of these are the same side. And what you would be able to say is that angle A, which is this angle here, is equal to angle B, which is also equal to angle C, which is all equal to 60. The thing you want to think about or make sure you understand is, why do they all equal 60? Well, if you remember, or if you don't remember, you do want to kind of learn this, that every triangle has 180 degrees in it. And so because there's 180 degrees in here, if everything is the same, you literally just do 180 divided by 3. And when you do 180 divided by 3, you get the answer of 60. So we'll actually see another triangle like this in the other side of our notes, which is the other stuff. But for right now, what I'm going to do is show you why it's 180 degrees, so you have the proof.
Hey, this is Mr. Leach with Simpson Math. Today I'm going to be showing you how you can physically see how the sum of the interior angles of a triangle do in fact add up to 180 degrees. To do that, I've taken some pieces of colored paper and I've cut them into some various triangles. I have an equilateral triangle, an obtuse triangle, and an acute triangle. Let me first show you with the equilateral triangle. So what you need to do is to draw a triangle on a piece of paper, cut it out, and label the angles A, B, and C. You don't have to make an equilateral triangle. It could be obtuse or acute. Just use your creativity. What you're going to then do is to then cut out each angle. Using a straight edge, I drew a straight line on this piece of paper. If in fact the interior angles of this triangle add up to be 180 degrees, then I should be able to fit them together like a jigsaw puzzle using this line as a boundary. So let's take angle A and put it up against the line. Take angle B, put it next to angle A, and then angle C should fit in right next to it. And in fact it does. So as you can see, that this is 180 degrees, because remember a full circle would be 360, so this is half, which is just 180 degrees.
I'm going to stop there because there's no need to do the other part. All he did was go back and do the other two triangles, so you could try it out for yourself. It will always work. So again, every triangle, the interior angles, which would be the three angles on the inside, would add up to be 180 degrees. Best strategy if you're trying to figure out what kind of triangle it is to use the process of elimination, which means the first thing you want to do is check to see if all the angles are equal, which means they're all marked or they're all 60. If that's the case, we of course know it would be equiangular. So if you're trying to classify a triangle by its angles, look to see if everything's equal. If they are, it's equiangular. Then you go and look to say, is there a right angle, which would be 90 degrees, or is there something bigger than 90 degrees? Because if that is the case, if there is a 90-degree angle, we know it's right. If there's an angle bigger than 90 degrees, then we know it's obtuse. And if it's neither of those or none of those yet, then we know it's acute. So it kind of eliminates the options down to where you don't need to think much. So again, your questions are the angles equal? If so, it's equiangular. Is there a 90-degree angle in there? If so, it's a right triangle. Is there an angle larger than 90 degrees? If so, it's obtuse. And if none of that's true, then it's acute. And it sounds like a lot of thought, but it really doesn't take that much time. You just kind of do a real quick scan once you practice it up, and it becomes pretty easy to do. So take a second, again, pause the video, mentally classify these triangles real quick, and again, see if you can kind of get those right, and then I'll discuss in about, actually just pause the video and I'll discuss it in about 5 seconds on the actual live video. Here, once I look at it, the angles are not equal, but I see a 90-degree angle, which makes it right, which makes this a right triangle. On this one, none of the angles are equal. There's no right angle. There's no obtuse angle. This has to be acute. Again, every single angle here is acute. Once I look here, I see 60, 60, 60, which means every angle is equal. That makes this equiangular. Here, once I see this 120-degree angle, that means it's obtuse, which means that this is an obtuse triangle. So again, what you're honestly looking for is to see if they're the same, or look at the biggest angle. In this case, the biggest angle is 90, so it's right. In this case, the biggest angle is 65, and they're not equal, so it's acute. Here they're all equal, and here the biggest angle is 120, so it has to be obtuse. In terms of by sides, there are three ways to classify it. Scalene means no congruent sides, and again, congruent means equal. So when you look at a triangle, again, this is not by angle, this is by side. So 15, 12, and 23 are all different, so therefore it's a scalene triangle. In terms of the work you're going to do, most triangles are scalene. Now, in terms of algebraic problems, they'll give you the other types. But again, most triangles that you face in life are going to be scalene triangles. The second type is called isosceles. That means there's at least two congruent or equal sides. And so you have a triangle like this. This would actually be called the vertex of the triangle because that's the part where the two things meet. That would be called the base. These would be called the legs. Just like us, if we stand, our legs are the same size or pretty much the same size, and so that would be your two legs of this triangle. So again, these marks, if you remember from your experience, mean that these two things are equal. Just like the angles, as long as each of these has one mark in them, that means that both of those have to be the same distance or same length. All right, so it means that HL is congruent to HJ. Then you have equilateral, which means every side. Again, lateral means side, and if you look at the name again, equilateral, equal side. So again, if you look up and Google what lateral means, you'll see that it means the side of something, and so lateral does mean side. And again, in this situation, this is equilateral because each of these has the same exact mark, which means each of these sides is the same. Now, here's what's special about equilateral triangles. Equilateral triangles are also equiangular triangles. They're also equiangular, but again, they're also isosceles, but don't let that confuse you because remember isosceles said at least two, which we have three, but don't let that mess you up. If it has three sides, it's called equilateral. You can call it isosceles, but it's called equilateral. All right, so equilateral triangles, again, are also equiangular because what you'll learn later on is that the angle-side relationship is that if two angles of a triangle are congruent, then if two sides of a triangle are congruent, then the angles that face up to them are also congruent. And in this case, actually, let me go back to your isosceles triangle. So since these two sides are equal, it means that angle L would be equal to angle J because that's what they open up to. Well, in this case, because all three sides are equal, it means that R is equal to P is also equal to N, which makes it equiangular. All right. So the importance of the words in this problem is so they can hide information from you. For example, a couple of algebra problems that I'll go through before I wrap this up. They'll ask you to find x and the length of each side. They'll say it's an equilateral triangle. Again, the word equilateral means that every side is equal. If we know that every side is equal, then we know we can take two of these sides, this side here, which is represented by 2x plus 2, and we can set it equal to 5x minus 4. Now, what was the purpose of our bell ringer? Because that is a problem that you're going to see on your quizzes and tests. Move that 2x because it's smaller by subtracting it from both sides. Bring down your 2 equals 3x minus 4. We now want to move this 4 by adding it to both sides, getting 6 equals 3x. We then want to divide both sides by 3, getting the answer of 2. Now, you do want to check that because you want to make sure it's right. So you take that 2 and you plug it in. So you can probably do the mental math, or you could use your calculator. 2 times 2 is 4. 4 plus 2 is 6. Okay, so 6 is the number in my head. 5 times 2 is 10. 10 minus 4 is 6. That's good. And then 3 times 2 is 6, which means that every side is 6, and we know that it works. Whenever you're doing algebra in a geometric problem, you probably want to make sure you plug things in to make sure everything is exactly what they said it should be. In this case, they said it's equilateral, so we should get the same answer in all three of them. But because it's equilateral, we could have linked up the other sides as well. So just check this out. We did 2x plus 2 to 5x minus 4. We could have also linked up 2x plus 2 to 3x and still gotten the answer because these two things are equal and algebra doesn't lie. So you would have moved the 2x over there, which would have made it x, and then 2 would have came down with x. Or you could have linked up the 5x minus 4 to the 3x, and you would have moved the 3x over here, giving us 2x minus 4 equals 0, because remember, if you subtract 3x, nothing's left. You would then add 4 to both sides, and then divide by 2 and still get 2. So no matter what happens, if it was equilateral, you could link up anything you want, which means strategically it's best to probably pick 2 of them that you think match up the best. Isosceles triangles don't work that way, but you just have to know which sides are congruent, but they usually tell you Find y and the length of each side if ABC is isosceles with AB equal to BC. Here is your statement here. You know that AB is equal to BC. And so what we can do is we can substitute what we know AB to be measured as, which is 4y. And we can substitute what we know BC to be equal, which is 3y plus 2. And then we just solve. Once again, move your 3y by subtracting it, getting regular y, bringing down your 2. Y is equal to 2. Now, again, you want to do a quick check because, again, it's a geometric problem, so that means these two sides should be equal. So take that 2 and plug it in. 4 times 2 is 8. 3 times 2 is 6, plus 2 is also 8. And they also want to know, well, I don't know if they want to know what the side is, but AC, if we know that this is 2, would be 6. All right. So that does conclude our information. Again, let me know if you have any questions. Email me for any clarification. I will respond as soon as I can. You can email me anytime if you're studying this stuff at 2 o'clock in the morning, which I don't know how you do that anymore. But if you're doing that, you can send it. I do have a do not disturb on my phone, so it's not even going to get through or bother me. But I will respond as soon as I can, as soon as I see what the message is. Outside of that, spend the rest of the time trying to pretty much practice that stuff. I guess, again, if you need the worksheet, send me an email. Let me know you need the worksheet, and I can send it to you. And outside of that, just pretty much work through anything that we do with standardized test logic, which means if you're taking a standardized test, you want to do everything you know how to do first, which means skip over some, but do the things that you absolutely know you know how to do. Then you try to do what you think you know how to do. So if you see something that looks kind of familiar, do what you think you know. You may not get it right, but again, ask for help. And then after that, you make your best guess on everything else. And the importance of number 3 is that what I'm trying to do is help you to get better at doing math problems, which means that the only way I can help you get better is if you have an opinion. If you don't form an opinion, then you're just kind of waiting for me to tell you what to think. But the best way for you to learn it is to actually say, I think this is what I do. And then I can take that and either say, yes, these two steps are right, but that's not. Or I can say, hey, that's right, so keep going with your instincts. Or I can say, change everything because whatever you thought was wrong, which, again, sounds bad, but that's kind of the process of learning. But outside of that, have a good day, and I will talk to you later.